All right, let's talk about cloud networking. I know, it's a topic that can sound super complicated, right? But I promise, by the end of this, you're going to see it's way more intuitive than you think. And to prove it, we're going to use a simple analogy.
So to get our heads around all this, let's just use a really simple idea. Forget all the technical jargon for a minute. Instead, I want you to imagine that you've been tasked with building your company's brand new, cutting-edge digital headquarters, completely from scratch. And we're going to follow a pretty straightforward construction plan. First up, we'll secure our plot of land. Then, we'll get to work building the interior and putting up the security systems. After that, we've got to connect our HQ to the rest of the world, manage all the traffic coming in and out, and then finally, we'll get to step back and admire our finished blueprint.
Okay, first things first. Any great building project has to start with a solid foundation on its own private piece of land. In the cloud, this is your virtual private cloud, or what we call a VPC.
Think of the VPC as your own huge, privately owned piece of property in the digital world. It is completely, 100% isolated from all the other plots around it. That means nobody can see into your digital land, and you can't see into theirs. This creates this really secure perimeter. It's the foundational boundary for your entire digital headquarters.
Now here's where things get really cool with Google Cloud's VPC. Unlike some other clouds where your plot of land is maybe stuck in one city or country, a Google VPC is a global resource right out of the box. This means you can build different parts of your headquarters all over the world, say in Tokyo, London, and New York, and they are all connected inside the same single private network. This is incredibly powerful because it just simplifies everything about managing a global business. All your international offices can talk to each other securely and privately without a bunch of complicated workarounds.
All right, so we have our global plot of land. Fantastic. Now it's time to actually build the inside of our headquarters. We need to put up some walls, create different departments, and figure out who gets to talk to whom.
And this brings us to a classic, super common problem. In a busy, dynamic headquarters, your employees, which are kind of like individual computers we call virtual machines, they might move desks or get replaced all the time. Their specific location, their IP address, can constantly change. So how on earth do you write a security rule that says accounting can talk to HR if you don't know their exact desk numbers from one day to the next? It's a real headache.
Well, the answer is just brilliant in its simplicity. You use tags, not addresses. Just think of a tag like a permanent job title or a department badge. Instead of trying to keep track of everyone's desk number, you just give all your public-facing web servers a web tier tag and your secure databases a database tier tag. Then your security rule just says, allow anyone with a web tier badge to talk to anyone with a database tier badge. That's it. It doesn't matter if you have 10 web servers or 10,000. The rule is based on their role, so it just always works.
So what if your company has a bunch of different divisions? Well, you could give each division its own separate office building, and that's secure, sure, but it's really inefficient. A much better way is something called a shared VPC. This is like having a central facilities team that manages the entire building, the main plumbing, the electricity, the security, while different company divisions can securely rent out entire floors for their own projects. You get that central control, but your developers still get their freedom. It's the best of both worlds.
Okay, our digital headquarters is now built and organized internally. But, a business can't exist on an island. We need to build some roads to connect it to our physical offices, and maybe even to other digital HQs.
To connect your physical office to your new cloud HQ, you've basically got two main options. For lower traffic that isn't mission-critical, you can use Cloud VPN. Just think of this like a secure, armored truck that travels over the public internet highways. But for massive amounts of really critical data, you're going to want a dedicated interconnect. This is like building your own private, multi-lane highway directly between your buildings. It gives you huge bandwidth and guaranteed reliability.
Now, what about connecting two separate digital headquarters? Well, if both of your HQs have totally unique internal room numbers, their IP addresses, you can use something called VPC peering. It's like building a direct private hallway connecting the two buildings. Super fast, super simple. But what if both buildings use the same room numbers, like 101 for their front desk? Well, that creates a conflict, right? That's where Private Service Connect comes in. It acts like a smart internal delivery service that knows exactly how to get packages to the correct room 101 in the right building, avoiding any confusion.
We are fully connected. This is awesome. But now we need to manage the flow of people and packages. We need a mailroom to handle all the outgoing requests, and we need a really smart receptionist at the front door to direct all the visitors.
So here's a common security puzzle. The servers deep inside your headquarters, right? The ones in the secure vaults with no public-facing doors or windows? They still need to get information from the outside world, like essential software updates. So how do they do that without exposing themselves to attack?
The answer is Cloud NAT, and it works exactly like a secure company mailroom. Any employee inside the building can send a letter out through the mailroom to go get updates. But the mailroom has a very strict policy. It does not accept any unsolicited packages from the outside. This lets your internal private machines reach out to the internet, but, and this is the important part, it prevents the internet from starting connections back in.
And finally, at the front door of your HQ, you absolutely need a load balancer. This is your super smart receptionist. When a visitor shows up asking for the video department, the receptionist sends them to the right servers. If they ask for billing, they get sent somewhere else entirely. For really special traffic, like high-speed gaming, it can even provide a dedicated express entrance. And most importantly, if one department gets too busy, the receptionist just directs new visitors to other available staff, making sure no single server gets overwhelmed and everything keeps running smoothly.
And just like that, our digital headquarters is complete. Let's take a step back and look at the blueprint of what we've just built together, piece by piece.
We started with our virtual private cloud, our global secure plot of land. We built our internal security using those flexible tags instead of fragile addresses. We connected our HQ to the outside world with secure VPNs or those private interconnect highways. We enabled secure outbound updates with our Cloud NAT mailroom. And we're managing all the incoming visitors with our smart load balancer receptionist. See? By thinking of it this way, you haven't just configured a bunch of services, you've architected a robust, secure, and scalable digital headquarters that's ready for anything.
Your headquarters is now a fortress, totally ready for business. But having a great headquarters, that's only half the battle, isn't it? The next big challenge is, how do you get your products and services out of that front door and into the hands of your customers all over the world, instantly and safely? Well, that's a story for our next explainer. Thanks for joining me.